We're also trying to figure out, how to scale these measurements and how to make them interoperable with other people's work. And I mean, I think we've run into a couple of pretty clear things that we're trying to address. One is just, at the Soil Health Institute, unlike the academic institution that I came from, where you have your own labs and you know exactly what's going on in your labs because you can walk in and check and you have written all the SOPs, et cetera, and developed the designs. At the Soil Health Institute, we don't have our own labs. So we also have to use commercial and research labs. We've really shied away from research labs because they don't have the throughput that we need and the speed at which we need analysis done, which really puts us in the same game as a lot of farmers and ranchers and soil managers, in that we need high throughput, good quality data. And really what we've inherited is this amazing laboratory network across the United States that's really good at fertility, but not necessarily well honed yet for soil health and soil carbon measurements. So I think that's like the landscape that we start at, right? Is that we have these labs compared to what the globe has. They're like really good, outstanding labs, great people, really nice foundation of understanding how to process soils and analyze soils. The infrastructure is there, but the infrastructure was just designed for something else, which is fertility and testing.
And then I just want to, oh, go ahead. Sorry.
No, go ahead, Rob.
You just had your annual meeting 2 weeks ago. Was there much discussion about the need for better data, need for in the cotton and textile space, or?
Yeah, not the need for better data. I mean, the question really is, how do you collect it and what do you do with it once you get it? That's really, when we're working with labs, we have put on our website now the SOPs that we use when we work with commercial labs. So that's what I was going to say. One of the things we've kind of done with labs now is that we have our own set of SOPs that we've created working with commercial labs. So we have those available and anyone can refer to them if they would like. They're on our website. So that's kind of how we dealt with like the interoperable component of the lab. But I want to point out is it's not just the lab analysis, it's also how the soil is processed. So there's kind of two big components to like the interoperable component. But then the really important component when, Rob, when you're talking about like, what do we do in the textiles and, industry, we're working with Textile Exchange, BCI, a couple of the cotton oriented groups, is we really have to also know what the management is. And what we've learned is when we go collect a soil sample, we spend as much or more time getting that management metadata than we do actually collecting the soil sample. In fact, many times after we've gone out and done a huge campaign, which we have done in our cotton work, we spend really more time going back and making sure that we have the right management data. And we really spend a lot of time on like how to, so that anybody at SHI or working for SHI could do the interview and get the information that we need to make sure that all the data have a clear set of like, and the crazy thing is it's not just how the soil is managed that day, right? Or that year. Soil health is really an interpolation of many years of management. So that's kind of a tough component of it as far as, data quality and the interoperability. But at the end of the day, the biggest component to the analysis side is that we know that every soil can be healthy. It can express its maximum capability to perform ecosystem services. However, the context of that soil, the soil's texture, what the soil is expected to be doing, and where the soil is in the landscape and in the climate, affect a lot of how we're going to interpret the data. So that again gets to the importance of the metadata.
Got it. And I think what you're calling out was something that was earlier. I think Dennis from Purdue Oats called out the need for integration with farm management information systems so that we understand the management practices and the soil status and so forth. So I want to kick it over to Lakeisha Odom You're the science program director for soil health at the Foundation for Food and Ag Research. And can you talk a little bit about how you're viewing the need to close the soil data gap, if you will, to inform science and practice and service providers, and what you're doing about it at FAR?
Absolutely. So, basically, FAR is looking for opportunities to identify research gaps and also support additional research through that public-private partnership space. And we recognize that data or soil health data is kind of the perfect kind of meshing of both worlds of where we work. So we recognize that it's mission critical in order to inform and provide solutions, right? Because that's kind of what we want to move towards, that we have to be able to address that gap. And in the previous two sessions, I was really excited to see a number of partners we've worked with before and a lot of familiar faces, but also some new faces to the space, and then figuring out how to connect some of these disparate efforts, right? I think we talked about that in the previous, and we'll hear that theme kind of keep coming back, where there's a lot of great work, but how do we kind of maximize it and start to move closer to being able to work in a more standardized and cohesive way? I think that's what I'm hearing a lot of people desire, and that's exciting because that means that likely we're more inclined to get there. Thinking about some of the things that we've funded, I'll highlight maybe 3 projects. So you heard Dawn talk about Open Team. So far as invested in that. We've worked with Soil Health Institute and supported some of their health metrics work. And we also have funded some work with the Oats team out of Purdue. So we're really interested in figuring out how we can enable interoperability, all geared toward increasing and improving decision support and the rigor of that. And then looking at how we can standardize. So I think a lot of the conversations having today, far as either work with partners or we're thinking about how we can design projects in those spaces. And then a project that is newer that I'd like to talk about a little bit is our ag mission work that is led by my colleague Allison Thompson from Field to Market. So some of you might know her name. And we're in partnership with the World Farmers Organization, trying to figure out how to achieve net zero ag greenhouse gas emissions in the ag sector. And one of the key areas that they've identified as an emerging need is how to access and use the wealth of data and knowledge in our ag systems and climate. And much like Christine just said, like it's data, but it's a lot of it. What do you need? How do you sort through it in order to answer some of the more complex questions? So one of the primary initiatives is through our Ag Mission initiative, is to try to address this fragmentation. And so one of the aims that they would like to push forward is to increase the use of fair standards for ag data, specifically data necessary for climate mitigation and adaptation research. And so they're hoping that that information is not just available, but machine actionable. And then the next piece is that Ag Mission would like to develop a visual navigation tool. And the outcome has the potential to transform the ability for ag sciences to benefit from advances in computational science. And we hope that will accelerate research and improve accuracy and utility of decision support tools in those spaces. And we've hosted a number of convenings around data privacy. And so that's another space that we're interested in. So I would say that FAR is interested in continuing to figure out knowledge gaps in this space. But we definitely understand that like figuring out how to enable more interoperability and standardization is mission critical.
Excellent. Jane Zilakova, I'm gonna kick it over to you. You're the executive director of the Soil Carbon Solutions Center at Colorado State, which of course is the home of the Comet Farm Planner. And let's talk a little bit about farmer education. How could calibrated soil-related data help farmer education? And also, maybe you can talk a little bit about the work you're doing to look beyond carbon, looking at things like new microbial models.
Yeah, maybe I'll start there and then work my way to farmer education. So CSU is a great place for data and models. As you mentioned, CSU developed and continues to host the Comet Farm and Comet Planner tools that are funded by the USDA and essentially help anyone, farmers, whoever, sort of simulate different management approaches and look at outcomes, including sort of greenhouse gas emission outcomes and other potential areas where farmers may want to shift their resource footprints. So I think it's really important from a data and model perspective to think beyond sort of the models we already have and continue to advance and evolve models to better incorporate and simulate what we now know is happening in the soil when we shift particular management practices. One of the kind of more exciting things that are happening here at CSU is the incorporation of microbially driven processes into the next generation of models, because now we know microbes are largely responsible for the transformation of various nutrients in soil, including carbon. And we now have a better understanding of sort of the roles that microbes play and can better represent those roles in models. And so there are a series of models that are being developed at CSU and other places, including the MEMS model, which is a CSU model that both incorporate the microbial component of carbon transformation, nitrogen transformation, water, but also think about the different kinds of carbon that exist in soils that have different residence times and sort of are differentially impacted by management. So in particular, we're thinking about things like particular organic matter versus mineral associated organic matter, and that management practices sort of impact those pools of carbon differently and at different time scales. And so the models are able to model that particular element better and therefore have potentially more accurate results and more scalable results. So that's a really important part of what's happening here, is just kind of pushing forward and developing better models that represent real world kind of activities. And then the next piece is that, you know, a model, I tell students, I teach garbage in, garbage out, like a model is only as good as the data that populate and sort of move those models forward. And so a really important piece of building good models is having good data that are accurate, and a big part of accuracy is knowing that we can trust the analyses, right? We can trust the way that the samples are processed, that the numbers that come out at the end are real. And so that kind of links to a lot of the conversations that have taken place. And we're doing some work at CSU to actually quantify how different processing approaches, like procedural variations along each step of processing a real sample of soil, impacts the final number. Because we know intuitively, and with all the conversations that just took place in the last session, that that's a really big issue, and we're going to quantify that here. And so then in terms of how that translates to farmer education, I think it really sort of depends. Are farmers going to be running models? Probably not. Are farmers coming to Comet Farm or Comet Planner to sort of figure out how to manage their land? Maybe, but not maybe as often as we think. And so there is a difference between the activities that we're doing here, the models we're developing, and the data that we're gathering, and what's actually relevant to a farmer or a rancher who's just trying to figure out how to manage their land. But I think there is a lot we can do in terms of farmer education and helping producers have the tools they need to actually plan for particular outcomes. And we can't tell them what the outcomes should be, but we should have lots of options for them to be able to use whatever platforms we develop as a platform for planning and for optimizing particular outcomes.
Excellent. Let's jump over to Chelsea, because you talked about the work you've done with Tomcat, but you didn't really touch about how that Tomcat data is part of a larger set of interoperable, calibrated data that Point Blue has pulled together in the form of the Rangeland Monitoring Network. Maybe you could talk a little bit about that, how that has benefited ranchers in their decision making. How's that?
Yeah, that sounds awesome. Thanks, Rob. So in session 2, I was able to talk a little bit about, the data that we've been helping to collect at Tomcat over the past 12 years, which included those sort of standardized 40 points that we collect information on using those standardized methods for birds, plants, and soils. And that's part of the Rangeland Monitoring Network. So it was established in partnership. This network was established in partnership with Tomcat Ranch in 2014, and it now is used to monitor rangeland ecosystem function in a standardized way across over 100 ranches in California now. So mostly privately owned and working ranches. And there's dual purposes for the RMN, and one is to support on-ranch decision-making and storytelling. And so at many of the ranches, so we are partner biologists. We have a partner biologist program that is a cost share program with the Natural Resource Conservation Service, 50-50, and through the NRCS portion of this agreement, our staff go out and leverage Farm Bill dollars to implement conservation practices and conduct conservation planning. And with Point Blue, we're able to bring in some additional ecological monitoring to the picture, which is how we're able to get the rangeland monitoring network on the ground statewide. We're in over 25 counties. And so our partner biologists are able to form relationships with interested ranchers. They select points using these standardized approaches that are randomly selected on a given ranch and monitor them over time, and sit down with the ranchers to help them understand what their data are saying. We provide that information back to them in landowner letters. So really trying to use those information to inform the stewardship process, where folks are at and where they're headed. I'll say that there's other ways that with additional planning mechanisms that are coming online in California. So for instance, carbon farm plans are really big. We have had a number of scenarios and instances where we're able to work with local resource conservation districts and integrate the data that we collect into the carbon farm planning process. So really trying to maximize this information to help at the ranch scale. We do have a lot of ranchers who are also interested in using the information to storytell, right? So through direct to consumer storytelling, for instance, at farmers markets, and we will, to the extent that we're able, provide support in that to them. At Tomcat Ranch, one of the ways that we sit down with the land and livestock team every year and look through the data and really roll up our sleeves and help make decisions about, what fields might need to be rested in the winter based on soil compaction, or where are we headed in the right direction and keep management the way it is, or we want to switch up management. So lots of different ways that it rolls out at the ranch scale, but really that is one of the main purposes. Now, our ability to provide information at the ranch scale is aided by this network of standardized data. So the indicators are only as good as your ability to interpret them. And your interpretation can be aided by understanding what's possible in a region for a given soil type, for instance. And so if you can imagine, we have 100 ranches that are collecting data, that we're collecting data on in the same way. And within each ranch, we have a certain number of points. So we have hundreds of data points, and we're able to create, for instance, soil health curves by region and soil type. And those soil health curves can help us interpret the information with the landowners to say, okay, no, you're setting the curve, or you're pretty low in these points. You may want to think about what you can do there. The aggregating at scale, also, we do science around it. So it helps us understand sort of where the status of California rangelands in general. And that's important for many reasons. And folks, there's also a lot of policy relevance there. So thinking about, if and how the information that we collect can be used to support climate scoping plans in California through, or the CDFA Healthy Soils program is, seeking to generate maps of agricultural lands. And if we have this rich data set on privately owned working ranches, I think there's a lot to contribute there. Yeah.
So just one thing. So not to knock it, it's only 100 ranches though. How do we put a rocket booster on this thing? So can you talk a little bit about like range C, for instance?
Yeah. So we in sort of the evolving landscape in California in particular, we've seen a real opportunity to sort of evolve the monitoring that we do on rangelands, in particular in relation to carbon, and map it onto policy and planning mechanisms that are emerging. So CDFA Healthy Soils program, you have that incentivizes healthy soils practices. You have private versions of that with Zero Footprints Restore California program, and carbon farm plans. All of these mechanisms that are incentivizing and helping to plan for the implementation of conservation practices that can rebuild soil health on rangelands. So as we're on the ground, through our partner biologist program, helping to implement in many ways, and then also monitor, we saw a need and an opportunity to map our monitoring onto specific practices and help people when they're on the ground collect information associated with an area where they just put a hedgerow down, or an area where they put a windbreak, or where they just put compost. And so we, with support from the Foundation for Food and Ag Research and Tomcat Ranch and others, we worked with 35 scientists, internal to Point Blue and external, to develop the Range C monitoring framework. And so that the idea here is that we will have a rigorous but accessible carbon monitoring framework that can be used to serve multiple needs in a decentralized way. So there are minimum standards, but really it's about the creation of an interoperable data set, because we designed this to be fit for purpose. So there's a fit for purpose decisions throughout, with the hope that if you offer flexibility in a framework like this, it will be widely accessible and more widely adopted. And with that, you need something like a transparency for decisions that are made in that framework. So we've also created a way to have an inference scoring system. So these decisions you're making around monitoring, how many points are you going to have? How did you choose your points? Did you monitor control? Those are all, did you monitor plants and soils? Those are all going to lead to an inference, it'll affect your inference on how carbon is changing. And we capture that in this framework. And it really has these dual purposes, again, to serve on-ranch needs, communicate through the supply chain, help people manage adaptively, but also be aggregated at a network scale. And so there's a big informatics component here relevant to this. And I just wanted to mention that we are working really closely with our side and Survey Stack and Open Team in this tech ecosystem to lean into what others are doing to create these common management data systems for management, but also environmental data. And I feel like I'm talking too much, so I'll stop.
No, that's great. I mean, I love it. I love we're talking about interoperability of people. That's important. Chris Covey, I want to kick it over to you because you have a bit of an odd background in the sense that you came from forestry. And I think that when you found out about ag, you saw and particularly where we are with soil data, you saw the need for us to pull up our socks. And I think that inspired you to start the Soil Inventory Project. Can you talk a little bit about that gap between forestry and agriculture?
Yeah, thanks for that. I'm not a soil scientist. I was a forester by training. I started playing in soils and carbon maybe in 2015 after we had done a global tree count. And that effort was aided by this massive effort to inventory forests. And I think it's important to note that we haven't always been there. I had one of my academic advisors, this wonderful guy, used to say that no society had ever come to the sustainable management of a forest resource without first cutting to the other side. And the Germans cut to the other side of their forests in the 1700s, and then they developed the initial concepts of sustained yield, right? And that's where we get the word sustainability from, is from forests. And then the word, regeneration comes from forestry as well. And the sort of in the basket of cliched hackney phrases from forestry is this: you can't manage what you can't measure. And the idea that if you want to set up sustained yield, that's an accounting problem, right? And so you have to have methods for inventory. And that inventory needs to be widely applied. And it needs to be low cost. If the inventory costs more than the value of the information that you get from it, then it's worth less than nothing, right? And so as societies cut to the other side of a forest, they then start to do really careful inventory as it grows back, and they start to develop sustainable and then regenerative management systems based on these accounting problems. And when I came to soils, I heard over and over again things like, things like, oh, well, the system is so variable. And I thought, have you ever been in a tropical forest? I mean, some of the trees are this big and some of the trees are this big, and they're 200 species per hectare. And yet foresters go out and inventory this stuff all the time. They haven't even named all the species yet, and they're doing inventory and efficiently at scale, using common methods that have been developed over 2 centuries of methodology. Most of what a forester does is inventory. Essentially, foresters are paid counters, and they count wood. And we've been doing this at large scale, particularly in the United States. We have huge congressional budget lines, millions and millions of dollars a year that go to a national forest inventory that provides us with tremendous benefits. And those are commercially applied to managing large plantations, to managing natural regeneration and complex forest systems, to supporting carbon markets and all kinds of innovations in carbon markets that we're not even close to thinking about in the soils world. And so I think we have a great deal to learn from forestry, both in terms of how foresters do inventory at scale, things like, you know, the trick measuring the diameter of a tree and having models that relate it. So there's this sort of model type development that we see happening in all of these tools that people are applying, like spec models and things like that. I see a lot of relationship there. The remotely sensed models applied to forestry obviously are much, much more advanced than soils for a couple of reasons. One, they have a lot more data to feed the machine, and two, they can actually see the things that are above ground, which is a pretty big advantage over what the struggles that soil scientists have. But markets have capitalized on all of that, as have land managers. And I think that we need, as everybody here has kind of agreed, this the on the ground data for things like carbon at scale that applies to managers, but that also needs to be added up at landscape, regional, and national scales to understand larger trends and how they relate to soil type practices, cropping systems, socioeconomic variables, and all of that is dependent on this ability to get a high resolution, large scale soil carbon layer, a national scale inventory. And that's what we're trying to do at TSIP. Looks a lot like what the USDA Forest Inventory and Analysis Program does. And that is a large scale field campaign run by the USDA, but you can envision a very similar system run by folks doing distributed inventory. So maybe I'll stop there. I'm beginning to babble.
That's great. I want to throw it over to Matt Wallenstein. So you're the chief soil scientist at Syngenta, and clearly you're looking at how you can enable regenerative farming practices across the globe. But then also you're looking at another important thing, which is making sure farmers maximize profitability. Can you tell us about the work that you're doing at Syngenta and why good soil data is critical to achieve that objective?
Yeah, thanks, Rob. So I think I'd start by saying that, you know, across the world, my observation is that the best farmers think about their soil first. They think about how everything they do on their farm affects the soil, and knowing that in turn, a healthy soil is going to deliver a healthy crop. It's going to deliver the yield that they're looking for, and it's going to be resilient to, you know, weather extremes and all the challenges that come along. So that's an important place to start. Now, at the same time, many of those farmers can tell you exactly to the penny, you know, how much their inputs cost and how much it costs to take their grain to the nearest mill. They can tell you exactly how much yield they got on any particular part of their field. But these same farmers that are thinking about their soil all the time don't have access to that quantitative information about the soil. Instead, they'll tell you how spongy it is, or how, you know, dark it is. And, you know, sure, that they'll get soil tests, but they just don't have that same ability to be quantitative in the same way they are with other types of data. And we need to fix that, because we know and they know that the soil holds the key to their success. And when they think about success, of course, it's a business. So they think about profitability. And they also think about their role as land stewards. They think about the role that they play in protecting the local ecosystem, protecting biodiversity. So let's think about how we can fix that. And when you think about what that means, it means we need to be able to provide low cost but robust data that they can then translate into action. They can translate that into decisions. We're not there. We're not there at all. We need to figure out how to do that, not just for those top farmers that have access to labs, but also for smallholder farmers across the world. So we need to both approach it from the sophisticated data-driven approach using models that we've talked about here, but also at the same time be thinking about what's the minimum amount of data that they need to make a decision, and how do we make that really accessible to farmers all across the world.
Excellent. That's great. Okay, I want to kick it over to Drew Zabraki from Semios. Help me out here, Drew. We've mostly been talking about cows and corn.
Right.
And I look at Semios as kind of a leader in specialty. Can you talk about maybe you should introduce Semios because some folks may not know it, but what you're doing to close that soil data gap, and how can you help producers, particularly in specialty?
Yeah, sure. Thanks, Rob. Well, Semios is an ag tech platform. We coin ourselves as the operating system of the farm. So we're about bringing a lot of information and data from sensors, human entered machine data together to drive insights in the moment. I mean, the last thing people need is more data, right? We heard both Matt and Jane talk about the farmers, and really what we need to get information into the hands of the farmer in the moment where they can take action. Right? Not a bunch of data, not a bunch of models that they have to figure out how to program. Farmers have 10 things to do today. Maybe 9 of them are going to get done, probably not. One of them is not figuring out how to program models and maneuver through reams of data. And so I think that's similar, whether we're talking about ranchers, if we're talking about commodity crops or specialty crops. At the end of the day, interoperability and bringing the metadata that Christine spoke about, and correlating that to the sense data and the lab analysis to drive insights that actually enable a producer to make a meaningful difference in their business and the product that they produce and in their environment. I mean, that's really the key that we're trying to unlock. And in Semios, we're looking at how do we accomplish that, right? There's and one of the gaps that we see are the same gaps that we've talked about today. It's interoperability, it's frameworks for data exchange that also address things like correlation of related data sets, like the metadata that Christine spoke about, addressing the privacy and use components that Lakeisha talked about, right? These are the gaps that are out there. That I think as an industry and the folks that talked about today and the different groups are working on will come together and address. But fundamentally, the issue that we're focused on is how do we empower growers to use the insights, the derivatives that come from this data in the moment? Because what we're finding is that the growers really don't have the technical resources, the knowledge, or the time to be able to process all this information. And the information is also quite varied. And so even if we program these models into their operating systems and we can send them insights in the moment, if the data, garbage in, garbage out, I think was mentioned here today, if that data is out of alignment or not calibrated, then the models break down. And so the gap that we're specifically addressing in Semios is how do we ground truth that data using sense data, image data, lab analysis, and then build algorithms that can normalize and reduce the bias of that information to where we now have consistent insights that we can feed to the grower. So we're working on a grant program with Canadian government and several academic institutions. It's about being able to use these various different sensors from LiDAR and image processing and soil and tissue sampling and try to develop algorithms that can help to take these vast and varied data sets and normalize them so that the algorithms can be used and trained and calibrated to make better decisions. So it's a big green field. There's a lot of work to be done. We're not even close to where we need to be, but it's exciting work, and I think it helps to fill those gaps of making those insights useful.
That's great. We have time for conversation. Jane, I'm going to kick it over to you because you seem to have lit up the chat with your comments about education. Well, starting about farmer education, and that kind of looked at curriculum training and so forth. I don't know if you want to weigh in on that, or anyone else, any of the other speakers.
Maybe Chelsea and I can talk about the joint effort between CSU and Point Blue to develop carbon ranch planning education tools. I think Chelsea can probably talk in a lot of detail about what that is about, but I'm happy to have lit up the chat and happy to hear garbage in, garbage out continue to percolate through the chat room. That's great. Yeah, I don't know. I can go through the chat and answer some questions. Is that what you want me to do?
Well, yeah, or you maybe want to take a look at it and see if there's any, we can circle back to you and see if you have any words of wisdom. Any of the other panelists have anything? Chris, I saw you reacting to something that Matt said there. You want to weigh in on that?
Yeah, I mean, I think this idea that, you know, farmers have a really good idea how much a bale of cotton gets them and how many bales of cotton they're likely to get. And when they talk to fertilizer reps or crop consultants, they can tell them, you know, oh, change your soil pH is this and add this much of this and your soil pH will go to this. And then that will change your yield to this. And it costs you this much to do it. And you get this much back. And a farmer can say, oh, well, of course I'm going to do that because I make money when I do that and I'm a business person. And then we're having all of these conversations about this concept of regenerative agriculture, the concept of soil health, or we're talking about the need to build carbon. And then we're telling them, if you do this thing, you're going to get more carbon. Well, how much more? Well, I don't know, more. It sounds good, doesn't it? Organic matter, it sounds good. And you're going to get more yield. Well, how much more yield? We need to be, and oh, you're going to get drought resilience. Well, and so you're going to outperform your neighbor when times get hard. Well, how much of that do I get? And what is it worth? And you have to be able to, fundamentally, you have to be able to measure that metric. If it's carbon in this case, or soil health, you have to define what the metric is, and then you have to be able to measure it. You have to be able to measure it at a cost that provides actual value so that a farmer can put it on the balance sheet. And once it goes on the balance sheet, it will be managed for, and the farmer will respond to incentives. But we have this idea that it's such a good idea. We're just going to tell these farmers what a great idea it is to do these things and tell them they're going to get all these benefits and they're going to run out and do these things that are good for everybody in theory. But we don't know what it costs us to get that change from the farmer. We don't know what the farmer gets for it. We don't know what we get concretely in the end. And so that balance sheet question, I think, is when we talk about a theory of change, the balance, putting carbon on the balance sheet of every farmer, small, and I think Matt also made an excellent point about this not just being for big, huge operations or rich. So this needs to be something that every farmer can afford to do, especially because these methods often are linked to low input kind of farming, which transfers well. And also the benefits come, the science seems to indicate that the benefits come disproportionately to marginal areas, right? And so these are places that don't have a lot of money to invest in inventory. So that needs to be at the front in terms of balance sheet. So I just think that is what all of this sort of fixing the health stack is about, data interoperability is about fundamentally getting that onto a farm balance sheet.
Matt, I think that's a raised hand there.
Yeah, I couldn't find the virtual raised hand. So Chris, you brought up an important point, which is what is the value of soil health? There ought to be an innate value to the grower in terms of, you know, the return on investment for yield and resiliency, but many farmers don't own the land that they operate, so that's one challenge. And even when they do, it's not clear that there's a signal in the land value, or at least that the signal is not where it should be. So if you improve your soil health, then, do you actually see an improvement in the value of your land? There was a study that came out very recently on effects or the relationship between converting to no-till and land, and happily there was a signal there. So I hope to see more of that, because you ought to be rewarded for improving that asset.
Chris, I see your hand up. I want to jump over to Chelsea though, and then I'll come back to you. Okay.
Awesome. Yeah, so I just had a couple of follow-up thoughts from what's been said already. So so on the point about sort of the leased land issue, I just wanted to give a nod to their Tomcat Ranch and California Farm Link just produced a guide to regenerative grazing leases to help to essentially overcome that challenge that that I think is inherent to the leased land conversation. So I just wanted to put a plug in for that, because I think that that is something that is really important. And then from thinking about how do we empower ranchers or farmers to make decisions and insights, we're obviously talking a lot about data and technology in today's session. And from my perspective, I think what is equally as important is communities of practice. And I think what I mean by that is, having a community, whether it's your neighbors or technical service providers or others who are on the learning journey with you to learn from, to share with. And I think at the end of the day, walking the land with somebody, and if you're not able to do that, and maybe even in addition to that, tapping into now these technologies that are meant to create communities of practice that can hook you up with folks who you might not otherwise be able to engage with. So Hilo and the coffee shop and things that Open Team are trying to facilitate there too, I think is such a critical piece of the picture, in addition to making sure that we have the informatics and the technologies and the data in the right place, in the right hands. That's also going to be really important in that picture.
Excellent. Chris.
Yeah, just to Matt's point, which I think is a hugely important one, about leased land and land value and the link to soil health. I think those studies that are linking soil health properties, metrics like soil carbon, to outcomes, to the extent to which we can improve the quality of that information and at scale, and understand it across systems, across ecological zones and cropping systems, that concept of putting that on the balance sheet is actually really important to then feeding it back into things like land value. And what I see, I had in the past month, I think 3 separate conversations with large investors raising funds around sustainable or regenerative agriculture, who are saying, can I get out and before I buy a piece of land, start to do soil sampling and integrate this into my due diligence process so that I can understand as an agricultural investor what it is that I'm buying and what the potential is. Where am I on these sort of curves that Chelsea was talking about? And so I think to the extent to which this information becomes more reliable and broader scale and linked to outcomes, we'll start to see that feed back into land value, but not just land value. I think you see crop insurers and ag lenders and folks who deal in risk all the time chomping at the bit for this information. There seems to be this understanding that, it must be linked to drought resilience. We have data that it is, but how, and how do I build that into a risk model so that when I'm lending, I can understand that? And again, this is the kind of information that we have at large scale for forests, that then the folks who are buying huge timberland, they understand where they are on the growth curve and how much wood they expect to grow in the next 10 years. And then how this property's fundamental sort of ecosystem productivity properties then lead to investment opportunity and return, and then that land has more value. And so we need similar systems for soil. That seems to be, again, his point about being on the balance sheet is the fundamental part of all of these.
Christine, you've been uncharacteristically quiet during this conversation. Can I call on you to share thoughts?
Sure. I mean, we've done a lot of these things that you're talking about, the partial budgets, communities of practice. Chris was talking about like sharing vast amounts of data that collected on large industry land for forests. But, we're collecting soil and management data on private property owners of various sizes. And I'm just curious about how you all have reflected on, even Jane has put out, like, do we expect farmers to do all these things? And I don't think we do. I think the idea is, how do we create like this infrastructure? Matt's representing a ag input company. What are y'all's reflections on data privacy and sharing of data? We can get on farmers' fields and we can collect the data to do a lot of the things everyone here is talking about. But for us to have access to that land, we have to garner trust. And we also have to be very careful with that data. And we have to make sure that we can ensure their privacy and the anonymity of the data. And I'm just kind of curious that, like, I know there's mechanisms for all of that. They all take a lot of investment. And I'm just curious about what all your reflections are. Like, all these things everyone's talking about is very doable, but it also requires this huge lift of sharing a lot of people's private data.
I'll jump in. I am actually amazed. The Farm Bureau was working on ag data privacy some years ago. We had OADA, but there is not there was some work being done at the University of Minnesota, but there is not a clear leader solving this issue. And I think that, farmers and ranchers are going to be practical. If they see value from the data that they're sharing, they're willing to transact on that data, but we have to make that clear, and they have to know how that data is being used. But I don't think that we still need leadership on that topic. But I also worry because too often that data privacy issue becomes the bottleneck, or it stops all discussion. And we can't allow that either. So there's a happy medium here, which is to make progress and in tandem address those data privacy issues. Chelsea's got her hand up.
Sorry, Drew, you can go and then I'll go. That's fine.
Go ahead, Drew.
I was just going to say, I couldn't agree more. Whether we're talking about supply chain or agronomy, whether in pork or produce or regen, within about 3 questions of a group coming together, discussing how this information can be used to drive insights and value, comes a question of privacy and data ownership. Like, it happens every single time. And I feel that you're right, Rob. We need to find a way to move past that. At the same point, we need to be mindful and appreciative that data used out of context or for an alternative purpose can be damaging. It absolutely is. And there's a number of cases in which that's true. I feel like there's an opportunity as we think about interoperability that we gravitate towards something that the Oat Center had put together as part of their open ag technology and systems framework for privacy and use components. It's not necessarily about data ownership or not sharing data. It's about what's the appropriate ways in which this information can be used within this context for these actors, and then enforce those use rights. And anything outside of those use rights then require another negotiation. And that all of a sudden changes the dynamic of, oh, I can't share anything, to no, it's fit for purpose and can be shared for purpose. And there's a framework for which we can guide that conversation. So I think there's more work to be done. And maybe that's an interesting framework to look into.
And as I pass those over to Chelsea, I'll just say my frustration is the technical solutions exist.
Right.
But we're not getting the adoption of those, and we're not highlighting them to have them applied at scale. Chelsea?
Yeah, I just wanted to offer some insights from, I think how the rangeland monitoring network has worked and some lessons learned there. So we're collecting information on, 100 mostly privately owned ranches in California. And I do think, Christine, to your comment that so much of it is on trust. And in our case, we were able to build trust through by having the folks who are collecting the data, they're part of the communities. So they live throughout the state of California, and they are embedded in NRCS offices, and they're forming trust with these ranchers through their jobs, but also just by living in the same community. And that is, I think, central to our success. Libby is the director of this program, and she's on the call. I'd be interested if she agrees, but I think from where I sit, that's really central to the success of the rangeland monitoring network, and then maintaining that trust. So you first build it and then you have to maintain it. And so really putting partnership and data privacy above any other needs or desires we might have for the data, really putting that partnership and that trust first and foremost, and making all decisions beyond that within that with that lens on top. And we do have our folks who participate in the network sign data sharing agreements. And it's pretty analog. We're not, I mean, they're paper forms, they can sign it. It's not real high tech, that side of things. And it's worked for us. And we give them a couple of options. Do you want to share your data freely with us to sort of do what we want? And you trust that we're going to make the right decisions there with latitude and longitude ascribed to it. And then there's a couple of other options that restrict that a little bit, but all of them allow us to share it somewhat. And so for what it's worth.
But geography is so important, right? If you strip these giant data sets of their geolocation, then you pretty much have lost 90% of the context of the information.
Yeah, absolutely. I think geographic information is critical. And there are scientific questions, I think, that do not require lat long as well. So I think that there are a lot of questions we can ask.
Soil questions that
I
don't
think if you want to aggregate, sort of, if you want to understand what is the average and variation in carbon stocks across the United States rangelands, you conceivably don't need lat long with that, just as an example.
And you're talking about aggregating and then anonymizing.
Yeah, so yep, exactly. And for the vast majority, I do think having lat long is critical. And if we're going to move forward, I think we would, I wouldn't encourage not having that, right? And I think going back to the example from session 2 with the Genomic Standard Consortium, lat long, I mean, that's just the base metadata that you need for points. And I'm not encouraging us to move away from that. But for the rangeland monitoring network, it is worked for our purposes to have, aggregating data as one option that, without.
Yeah, so we can certainly aggregate, right? But then the extent to which one aggregates, you lose more and more fidelity of the important, like the average carbon of rangelands in the United States, I could give you, but I mean, the important component is where the rangeland is and what climate is it in and what types of soils. I mean, we can certainly do that. I think it's just something that it's very, like, this whole group is about hacking interoperability of data. And I'm really interested in the fundamentals of SHI has a data set of farms with lat long on it. And certainly we can't share those lat longs. And the location is important, especially when we start to want to aggregate by soil type. And it's probably, like, I think all the technology is there, but having a clear understanding of like how it could work with another database, maybe that's associated with, Syngenta or Truterra or Bear Crop Science. And so that we could synergistically understand the state of soil health in certain soil types and certain geographies, but without, while maintaining that aggregation and anonymization. It's like almost like you have to disaggregate, do the analysis, and re-aggregate, right? To keep things anonymized. But then at the same time, like, you don't want to share your lat long data with an ag input company and then your farmers that trusted you to collect the data to find, to discover this. So I don't know. I think there's some more complexity and nuance to it than, the first hit. And I'm just saying, I think there's a lot of investment that is needed there, just so that like lay people like myself can understand what's that process and how do we keep people's data safe and advance science and achieve these goals that everybody here is talking about today. So I think that would be a great thing that any one of us could go to a site and go, oh, okay, this is how we can do it. Let's make sure that we follow those protocols or something. I don't know.
Well, I just want to give a shout out to Andres. Has some folks that are working on open data and data privacy. I don't know if that's specifically for ag, and maybe we'll hear more about that tomorrow. But I think this is certainly something where it would be good to understand both the technical solutions and I don't know if there's a Farm Foundation follow-up on data privacy. We haven't really had a good conversation, at least that I'm aware of, maybe for 2-3 years, on what are the solutions and where are we in the market? What would it take to get adopted? But Chris, did you have a comment? I think you
Well,
did.
I think Christine covered most of the things, and with Chelsea as well, in this idea of anonymized versus aggregated, and how that can work. And Doran's comment about consent, and understanding within these databases, not only, what's the practice on the field? How long has that practice been going on? What are the soil characteristics that were measured in the laboratory? But then also, what am I allowed to do with this data, and how is this data stored? And I think, referencing back to forest inventory and analysis, this is covered out by the U.S. Forest Service goes out, they ask landowner permission, and then they use the data, and then they share the data with researchers to make additional insights. And these aren't just big industrial forest lands, it's private landowners all over the United States that give their permission. And then it's you can be held criminally liable if you make that data public. You sign a contract to access the data from the federal government. Often you have to go and use a U.S. Forest Service computer, which you can imagine what that looks like. And then if you share that data outside of the contract that you sign with the federal government, you can be punished criminally. And so this idea that people give consent for data to be used in certain ways and aggregated in certain ways and then released to the public for public benefit in certain ways is established. And I'm not sure that we have, I think, again, that advantage is that this is the Forest Service doing that. I don't see this happening for soils and agriculture. And so what we have are the folks on this call trying to work it out, and us hopping on calls together and saying, like, where can we collaborate? What data are we allowed to share with each other? And to the extent to which we can think forward as we're making these agreements with partners and say, hey, I want to take on this data. Who can I share this with, and under what circumstances? I think that becomes thinking that beyond just our own use. And so at TSIP, one of the things that we've tried to say is, what's your level of comfort, or what are you allowed to do with this data right up front in those conversations? Is this data that we can share all the geolocations for everybody to see? Is this data that research partners can see? Is this data that only we can see? And then at what scale do we have to aggregate this data when we're done with it? Being really explicit about that and trying to actively encourage your partners to be as open as they possibly can be with the data. I think there is a knee-jerk reaction that somehow this soil carbon data is proprietary and super valuable to people. And I think there's a case where that's true, but on the whole, the more of this data that is publicly available and the better we understand how this links, the more valuable the data becomes to everybody. And so a lot of people's investment model would actually be benefited by this data being more public.
I think one of the things going on in agriculture, though, right, is the idea, like, are you held liable for the management that you do on your soils, right? So we may be just interested in soil carbon, which seems very benign, but with soil carbon comes management data. And that's my point that I tried to make at the very beginning, is this data is useless without the management data that goes with it. And with the management data comes liability. And I think that that's something that's just, I just wanted to, I'll be quiet after this. I think Jane had a great idea. It would be really nice to see some concrete examples of where people think that I think SHI, I think that we're like very protective of farmers' data, right? And we're getting consent agreements signed before we go on the fields that probably hinder us from sharing the data in very goodwill uses. And so for me, it'd be very helpful to see some really good examples of where there's a nice balance struck where the consent is there, but also the trust and the privacy is well articulated.
I think that's a great point. We've got new examples that we can call on, and then also new tools, right? So, like, Drew and Aaron have talked to me about confidential computing. Dorn has the wallet that he's talking about. He's talking about some of the things that Digital Green has, but I don't know if everyone's aware of these, and certainly we need to bring them all together and understand where are we and how do we set this up and knock it down. Jane, I want to make sure we don't want, are you there, Jane? Oh, there you are. Jane, I want to make sure you're not confused by Chris.
Oh, I can clear up my confusion with Chris. I was just, the forest inventory data are used and published all the time, so I was just confused about that, but we can talk about it separately. I will say, right now at CSU, we're standing up a modeling and data consortium that will be essentially a place where people can come and we can develop data and data resources and modeling tools together. And anyone who's a member of the consortium has access to those sort of tools as they're being developed, and any benefits and learnings come back into the consortium. But one of the things that folks have been asking me about as I'm talking to them about this idea is a lot of questions about data and data privacy. So I think one thing, like, it would be great to have just an in-depth conversation, and almost like I don't want to go to another event, but an in-depth conversation about this would be great. And if there's some way to put together a resource, or if a resource already exists and it looks like maybe there is one, where sort of all of these different examples and ways of thinking about data privacy are represented, that would be really useful as we sort of, because you're trying to sort of, you can't be everything to everyone, but you want to make sure that you're meeting the basic needs of people that are joining a consortium like this.
So maybe there's a white paper or something, and then we have a discussion to poke holes at that. We got an interesting request from Dennis Buckmaster to ask if he can unmute to talk about the sexy topic of tax preparation. And I'm going to take the bait. Dennis, can you talk
Okay.
about tax
Rob,
preparation?
maybe you or Drew have heard me say this before, but I think this role of data in agriculture, whether it was soil health, the management, what you did on your farm, particularly in the livestock realm, and probably direct to consumer foods, it would be more relevant. But I think a good analogy here helps, and it's taxes. Sorry to kind of raise everybody's blood pressure, but as a good citizen, I will try to pay my taxes fairly. And there are aspects of my life that in order to do that, the government must know some aggregated level of my personal life. So I go through a hired individual often. Well, in my case, it's just software, but a lot of people go through a trusted individual called the accountant, who takes folders, files, slips of paper, comments provided, assorted receipts, etc., and takes your whole personal year story and pulls out the things that the government doesn't need to know and includes the things that the government does need to know in order to generate a report that is, here's the part that you need to know, and here's the check, either send money back, or here's the check that, the account number that goes with it. And so whether, in some of these instances, we're not really talking necessarily solely about dealing with the government, but whoever it is, maybe there are aspects of the business that need to be relayed, and there are other aspects that don't need to be relayed. And that's the role of the accountant or the software. And I think that much of this talk that we're having here has to do with taking very specific things that I don't want. And there's no reason for another person to know those details. But at some aggregated level, the fact that I, used a certain amount of fuel, where I used it, that's my business. But if in order to get some tax credits, I have to tell some agency how much fuel I used on how many acres, well, so be it. I could do that kind of a thing. So I just wanted to throw out the tax preparation analogy. I think it's a little bit relevant.
Thank you, Dennis. I think we're over time, and I don't want to get Martha and Morgan mad at me. I'm gonna cheat a little bit, though. I want to thank that rock star.
Rob, you've got a little more time, so you can keep
Oh,
the
we do?
discussion going. Yep.
Okay. All right. Well,
All
I'm going to cheat a little bit because I know we're going to the breakouts, but I want to offer up my reflections on what we've heard today for you all to disagree with. The first is I've been really interested to see that we have had very little discussion about the 3-word soil carbon markets. It's been interesting that we haven't talked about verification. We haven't talked we're talking about healthy soils. And I think that's one aha that I had. The second is, I think that there is alignment, that there are serious gaps that we have in the healthy soils tech stack. And then the third is, I think that there's some general common agreement on what the challenges is. And then I think the thing that I'm really interested in, obviously, is what are we going to do to scale this up together? We know these issues, but how are we going to interoperate as people to find solutions that are going to solve this? We need to solve this. So at any rate, I don't know if anyone else wants to cheat and talk about reflections, any of the speakers before we break into breakout, but any other reflections, comments? Lakeisha?
So I think one of the reflections is that there's a lot of interest or maybe even a need to have additional conversations around like data privacy. I loved what Christine said, and someone else said in the chat around, I think it was Jane, the need for examples on where this is working well, right? And how can we figure out, because what I heard in this last series of discussions is that is a huge bottleneck for a lot of what we want to do. So not that we have to solve it, but just earmarking that could be a great kind of next step outcome, is maybe having additional, as Jane said, not another convening or work, but just another conversation similar to this one, where we think about what is out there, what's working, what's not working, so that we can think about how we could potentially address it. And as a research funder, look for those things that we could build a program around to maybe solve some of these challenges.
Excellent. It turns out I heard from Martha, we actually do have more time. So they're letting us keep going. So if anyone else wants to add thoughts, comments, criticisms, praise.
I mean, I guess about the carbon market. So I kind of am wondering if it's an intentional sort of, we don't want to go there because it opens up a whole new can of worms for this conversation. But maybe we should go there. I mean, I think in terms of the way that I think about carbon markets and data, is that carbon markets currently are built on what I will just describe as flimsy ground, like flimsy foundation that could at any point like sort of crack open and everything fall through, with a lot of bad consequences for climate, but also for the producers that are engaging in those markets. And so there is a need for really good, I think, data to underpin that foundation. If carbon markets are a thing that we agree we want to do, or that we may shrug and say are happening anyway, then maybe what we should be interested in is ensuring that the foundation upon which they're built is sound, and that we can do with data and interoperability.
And Jane, just to build on that, because I think it's not a question if we do soil carbon markets. There's a lot of people who have put out money and are out over their skis on this already. And the question, I have a concern that folks that have made those investments and are doling that money out could have a Wile E. Coyote moment where they're out beyond the cliff, and then there's going to be Chris liked that analogy, but where reality kicks in and we realize that this is all built on flimsy ground. And I think that's part of the reason that we need the impetus that to go fix the healthy soil tech stack, because we got to provide that better data. I don't know, Matt, I'm going to ask you. There you go. Go ahead, Matt.
Yeah, I think the question to me is whether carbon markets are really going to drive changes in management practices, changes in behavior. And I would venture to say that you get more value from improving your soil health, from building up soil organic matter, than you do from the carbon market itself. And so, I think the interest in soil carbon has on net been really good. It's brought a lot of attention to the importance of soils, the potential for improving soils and their role in mitigating climate change. Those are all good things. But at the farmer level, I think there's not a lot of evidence that they're really driving adoption of practices yet. And whether it's worth the investment to focus on measuring changes in carbon, which is hard to do, versus changes in soil health, which I think can lead to good things, both a return on investment to the farmer, plus all of the other benefits that come along with it.
Yeah, I would say, and when we did our partial budgets, farmers make more money off of soil health than the best paying carbon market today.
I would also throw my hat into the likely benefits from on the final product, but I think that's going to vary tremendously based on where you are, what you're growing. At the most extreme, we've been doing work with some winemakers in California, right? And their product, their sort of per acre value of those specialty crops is so high. And the amount of carbon they're likely to sequester pretty low, but in those marginal environments, little differences in soil carbon may have huge resilience benefits, particularly as we look to drought. And so if you're the producer whose vines survive a bad drought, that's the whole difference. Is going to completely tidal wave anything that's going to come out of that from a carbon market, even in a world where we're valuing carbon credits close to the social cost of carbon, right? The value in production is huge. And I think there's also a really interesting point on that sheet. I think was it just shaky ground? No, yes, very true. And I think part of that is measurement based. How well are we measuring carbon and the ecosystem response to management and quantifying gains from management? And then there's this whole other piece of that that's about market structure and what additionality means. And I think in soil, we're very much on bad ground in both places, and that's creating a whole lot of headline risk, not just for not just the like out over your skis, Wile E. Coyote, like I made an investment in this space, but also for the big brands that are flowing in and purchasing these credits and producing reports that say our sustainability is linked to this. We saw that again, looking at forestry as a leading indicator, with the number of Bloomberg articles with shaky forest carbon credits based on accounting structures that seemed like a good idea at the time. But once really smart people are trying to make money on these, you're going to see those systems get gamed. And then as soon as a reporter figures out how they got gamed, you're going to look pretty silly for that report that you published last year. So I think, again, looking not only to forestry to understand how we measure and quantify response to management over time and model it forward and build large data sets, but also to look at the forest markets, both for what's worked well, but also for what isn't working well. And we're seeing huge changes, natural capital exchange, whole new methods of trying to quantify change and sell credits, which, have a lot of things that seem really great about them. A lot of people are also critiquing these new methods. There's a lot of activity there I think we can learn from.
Rommel, you have your hand up. Did you want to say something?
It's Ramal, but my question, possibly Christopher knows this, is there a specific metric that reflects soil resilience to climate change as it relates to water? I know water retention is a metric, but is there anything that's specific to the soil itself?
I would bump that to Christine, Jane, and Matt.
It's called plant available water. So as soil structure improves, more of the water that the soil can hold becomes plant available.
Thank you.
Yeah.
And just to build on that, Christine, my question, so if we're actually looking at drought resilience as getting back to land value, how is that plant available water getting into the actuary tables of lenders and insurers?
Mhm. So that's a great question. And we're trying to develop like an app, a web app at the Institute. We've created kind of what Christopher was talking about. We call them pedo transfer functions, but essentially the same. How do you take something that you easily measure and make it get something that's more difficult to measure? Plant available water is very expensive and very technical to measure. But we've recently published a paper at the Soil Health Institute that shows how increases in organic carbon affect plant available water. And so we can predict it with a simple multilinear equation. So saying that we have this equation, again, if you're just saying, okay, we've increased carbon, and so now we have more plant available water, it's still just a bucket. And so the important component of it is really what you want to translate plant available water into is for your climate and your cropping season, how many more inches of water is available to the plant. And that requires modeling, right? Because climate change is different for every location. And so we're trying to make an app for that. Hopefully it'll be done soon so that you could just go in and say, if I increase my organic matter by 0.5%, how many more inches of water would I expect to have available to my crop during the growing season? Simple. And then that could turn into some actuary tables, right? That gives some information on drought resilience. It's all really complicated though, right? So now we've changed the soil so it holds more water, and how much water it holds and how much water it captures is going to depend on the rainfall. And we know that a 30-year estimate or 30-year simulation of average rainfall is no longer going to tell you what's going to fall this year, right? So you could imagine where an actuary could really play with those numbers, but at least we have the numbers now and we know what they are. It's just converting them into resilience, which is a few steps beyond my capabilities, but we can convert it into inches of water captured.
And Christine, is this a whack-a-mole issue where now Chris is going to have to go retest all of his sites, not just
No.
for, okay. So
No.
we have enough
You need
soil data points that we can model at least.
the information that you need is the particle size of the soil, this percent sand, silt, and clay. And then you need what you think your organic carbon is going to increase to. And so we know this, right? Like for the Midwest, for 5 years, changing practices, we have estimates of how much more carbon we think are going to be in the top 6 inches. So I think the information's there. I think the hard part, the science part is like, running the simulation, as Jane said, good data in. We have the pedo transfer functions. In fact, we put it into Comet Farm. I don't know if it's available yet, but it's in there. And so yeah, there's ways to do it. I don't think it's whack-a-mole. I think it's that valley of death, right? And tech to market scenarios, that valley of death is like getting it to scale and getting it commercial once there's proof of concept. So we have the science, we have the model, and now there's that investment in that valley of death to how to get that model so that someone who's creating an actuary table can take the soil science and get the number out, right? That's hard stuff. Actually, I have learned coming from being an academic to someone who thinks that they can do translational science, that, the science part is still the part I can do well. It's really hard to get it, Rob, like you're talking to that next step. It's not whack-a-mole, but it feels harder.
And Christine, I want to regurgitate Andreas's question so I can sound smart. Are these pedo transfer functions along the lines of Saxton 1986 model? And does bulk density play a role?
Yeah, so it's actually Saxton 2006 is what we've compared it to. But yes, but Saxton and Rawls equate. So our recent publication compares it to Saxton and Rawls. But it turns out that even though Saxton and Rawls had organic matter in it, it didn't actually account for, like, you can change the organic matter in Saxton and Rawls, but it doesn't change plant available water. And I could get a lot into why it doesn't, but probably no one's interested in that here. But there's a publication on it, it's open access, Hava has put it online. But yes, it's just as easy to use. Does it have bulk density in it? No, because bulk density is not an easy to measure soil property. No. We're trying to keep it easy and cheap.
I want to, Dorn, can you come off mute and talk about your environmental claims clearinghouse? That's kind of interesting.
Sure. So I mean, I think it was Chris who referenced that. But he sort of pointed to one of the challenges as you know, that certainly we're agreeing that the first and foremost value is in the agronomic value of soil health. But as soon as we start to have different, we're able to document change over time, we have different claims that are going to happen, whether it's scope 3 emissions on the corporate side, or we have public or private markets making claims. There immediately becomes a need to say, does this claim based on either soil carbon or water quality or other attributes that come with soil health, are they conflicting with one another? And so to go back to Dennis's point, there are lots of examples of clearinghouses in the financial market that do just this kind of conflicting sort of clearinghouse for claims. And so it just points to, I think, Christine's comment that we need more infrastructure. There's some key pieces that are data-driven infrastructure to allow for some of these functions to exist, to allow for these new, you know, vibrant markets that we'd like, and creativity in markets that we think we'd like to see exist, but that require a level of interoperability because to make a clearinghouse function, you have to define the geographic bounds, you have to have the, you know, the claim type, you have to have the claimant, the duration, like all those things actually have to be in a data structure that you can start to compare. And there's certainly work moving forward to do that, but it actually has to function at a minimum level to be able to answer just that yes/no question. Does a claim exist on this land? Can we develop a new environmental claim product for an individual or a group of farmers or not? And so I think those are some pretty important questions, both for individual producers navigating this, and you know, from the producer side, it's kind of the reverse. If you're buying land, does it have a claim on it? Is it encumbered? Or what's the potential? Who are the market? What are the available markets for this given piece of land? So it goes both ways, but it's really all about the same data interoperability.
Lakeisha, I saw you were either taking notes or you were just writing a check from the FAR checkbook for that
No,
greenhouse.
I wasn't doing that. I
Oh,
was
okay.
taking notes though. But this is something that Dorn and we've talked about. I think a number of folks, we've had conversations in this space. And I think even Steve had put something in the chat around looking at clearinghouses. So I like Tech Matters because they usually bring in perspectives from other sectors that we can make example of. And as Dorn said, there are examples of this that work. So how do we take that learning and translate it to our space to solve some of these challenges? So we don't have to necessarily reinvent the wheel, but we do have to create something that addresses our specific challenges in the soil health sector.
Yeah, we had someone else way up in the chat reference mining before. I know there's a lot of things from outside agriculture. It's kind of frustrating, particularly on this interoperable data discussion or data privacy, as ag was the first market ever invented, and we can't ever borrow from any other sector. For whatever reason, ag isn't that special. I mean, there are special challenges, but we should definitely look to leverage from other industries. Okay, we got 1 more minute. Does somebody have an incredible takeaway that they want to share before we go to breakouts? Matt, bring it home. What are you thinking?
Oh boy, there's some pressure and incredible insight. I mean, you know, first I want to thank the organizers. This is a really cool event. I'm excited to see what comes out of it, and glad Syngenta could sponsor it. You know, I think that the work that you all are doing here is critically important, because we know that there's information in the soil that can be tapped to really you know, make agriculture more sustainable, address food security, but we're not there, and we need your help to figure out how to collect data that's meaningful, and interoperability is really going to be critical. So just excited to see what comes out of this event.
Awesome. Let me just thank the discussion leaders. And then on that note, also just throw it over to Martha to tell us what we do next.
Just let me extend my thanks again to Syngenta, to this group for doing this. Fantastic discussion. I think there's a lot to follow up on, and really excited to see where the conversations go, and today and tomorrow.
And then we started to go down this path of, like, again, all of our lab infrastructure in the United States was set up in the 1960s, mostly to look at fertility, not really look at overall soil health. So what you have right now are most labs are cutting corners to save costs. So how do we actually, so soil health has these standard operating procedures. Then we started to go down, and so it turns out that there are two groups that are working on certification for soil health analysis. And there was confusion. We went down, one is called NAPT, something proficiency testing program. And the other one is called ALP, Ag Lab Proficiency. And so I don't know, I'm kind of, trying to think about, like, the evil global domination plan of how can we make, so Andres and Christine, I don't think they talked before, but so Andres is going to make sure that the soil health standard operating procedures are reflected in the MODIS 2.0 standard. Then we could actually go and take that to NAPT and ALP, and maybe there's a coalition of the willing that could start to, like, bang the drum together to say we need this built in, this data standardization for whatever that soil health standard is that they're developing. And then also take this to the tri-societies, which sounds like a secret society. And then one other thing, it turns out on a global scale, spectroscopy is actually standardized by an FAO group that we ran across, actually called GLOSOLON. And there's a guy named Rich Ferguson at NRCS who actually participates in that. And I'll shut up. We went deep in the weeds.
Thanks, Drew, or thanks, Rob. Drew, do you want to go next?
Yeah, that sounds fantastic. Well, I've got a report out in the morning, so I'm going to save some
All
of
right, I'll
this.
save yours.
But I'll give you a high level. I had a rock star group, and yeah, we had Sunisa Sharma, Russ Concert, James, so Jane, and I should be able to pronounce a Z last name, you would think, right? Chelsea and also Georgios. We had some good people, and we started talking about privacy. Just like we opened up that can of worms and we dug in and threw it all over the table, and we have some wonderful insights around how we're going to skin that elephant. We'll talk about in the morning. But then some of the conversation really moved towards the economics, and how do we create a sustainable business? How do we create and retain value? How do we discuss that in a way that empowers farmers to take action and communicate that amongst the stakeholders? And some really interesting conversation around that, and some of the impacts it may have for not just the farmers, but for our environment as well. And then, oh my gosh, I have so many notes and haven't read them all. And then we heard about some great examples of using certification and standards, or maybe labels and brands, as a way to communicate value, and what are the opportunities there, and how does interoperability, data exchange, privacy, and the financial impact play a role in that conversation. So that filled up most of our talk, and we'll have some more to share in the morning.
Awesome. Dennis, do you want to briefly give us
Well,
some?
Martha took a note, so I'm going to let her talk.
Right,
But I do want to change the paradigm. Drew said he had a rock star group. Well, when we consider the good of all mankind on the planet, do rock stars do much? I don't know. We had a farmer group. Like, we had the group that really makes a difference to the propensity of human goodness.
We had an
What do
international group.
farmers listen to in their earphones.
Yeah. Our group was interesting too, because we had folks from Australia and Canada and India joining us. So hearing a little bit about some of the challenges that they have versus what we have. So kind of a little bit of a preview of our Beyond the US session, I think a little bit, but we actually talked quite a bit on the data sovereignty issue. So I wonder if that, and Drew, I've got lots of stuff to talk to you about on this, but kind of, what do we learn from the other industries? How do you, connect things in a way that, respects that, but especially when you're dealing with the things that were coming up before us, latitude and longitudinal data, what are you going to do to sort of capitalize on that? And I'm trying to find the name of the group in my notes of that Steve referenced. Dorn, you guys got a plug for your biweekly conversations on legal standards and other talking about examples of where sort of data governance is working well. And the topic came up of, it would be great if we had a place for where people could highlight their examples, know what's working well, know about some of these initiatives like the digital green, et cetera, so that folks kind of knew what are the best practices for protecting privacy and working this stuff out practically. So lots more there, I think, to come. Did I miss anything, Dennis?
Oh, that's good.
I think that just brings us to Dorn.
Great. Well, I think the theme is we had great groups here. We had a lot of representation actually from California in our group with Jessica Chiardas, with Davis and Rommel from UC Berkeley, and Rebecca, well, I guess Rebecca Kini's with Indigo, and Jenna Fooding, who's actually an Open Team Fellow, which I forgot to mention, which is sort of filling this technical assistance, digital intermediary role. We have a few Open Team Fellows actually attending here. So I wanted to call them out because they're really putting themselves in this role with farmers, kind of what Dennis was mentioning, that fiduciary role in helping aggregation. So I just wanted to sort of celebrate their participation here and starting that process. And we also had Chris Covey was with us, and Jennifer Wood actually joined from California Association of Resource Conservation Districts. So lots of California. Great conversation. I think we started a lot with maintaining data. How do we maintain confidence in data integrity as we try to aggregate data across scales and recognizing both the challenges we discussed about of confidence in the quality, both for markets, but also for academic and for peer-to-peer use. And particularly the requirements for data structures and processes to gather that additional information up front, and then obviously the maintaining that. So we ended up with also, Jessica shared a lot about the scoring system and the idea of how we can create a industry-based scoring system that also supports good agronomic data gathering and practices, and how that can be interoperable with existing certifications and digital certification processes to reduce grower sort of the data entry burden for growers. And got a good overview of that. And I think that a lot of the remaining discussion was again looking at the importance of interoperability not only within labs but also this public-private boundary for sharing grower information across public and private boundaries with, say, USDA programs being able to share information with private marketplaces and so forth. Yeah, I think that was the general gist of it. I will quickly, I think we did also comment on this idea of again, I think a real theme was just making sure that we're creating, as was just mentioned with I think it was Rob, you're talking about the protocol or standard operating procedures in lab environments. I think where we intersect with that is thinking about the tools for enforcing those checklists, and that those create metadata that could then be integrated into a modus process, and that's as important. That sort of comes back to, I think, sort of the theme that we're working on is how do we make sure we're building the tools that capture all that additional data in a form that allows it to be aggregated with confidence and build trust without adding producer burden.
Thanks, Dorn. So thank you everyone for coming today, for joining the breakout rooms, taking a lot of time out of your day. I know we've got an exciting day 2 tomorrow, so I won't keep you all too long here. I'm just gonna pass over to Martha to do the final closeout, and we'll move on for tomorrow.
Thanks, Morgan. So yeah, thanks everybody for joining us today. You can keep chatting actually through the event website. If you'd like, that chat will stay up there. Tomorrow we'll get to actually hear a lot more about the hackathon and what's going on there. So we'll kick off with that, and then we'll kind of get into the weeds of what's happening there. I think learn a lot more about that Modus 2.0 standard. Andres is going to really spend a lot of time showing us that and talking through it. So I'm excited for that, especially given what Dorn and Rob have just mentioned. So, and we'll talk about beyond the US and the beyond carbon conversation. So we've actually kind of previewed a lot of what we intended to cover today. So looking forward to that. You can keep the chat going, reach out to folks through the event website, and we'll see you tomorrow at 10 Central. Thanks everybody. Bye.